Hello PS and Math 1 students. In this video, we are going to talk about trigonometric functions of an acute angle. Previously, you have already learned about the definitions of trigonometric functions. So as a recall, we have this one. Let t be a real number and let x, y be the point on the unit circle corresponding to t. So sine t is equal to y, cosine t is equal to x, tan t is equal to y over x, where x is not equal to 0, cosecant t is equal to 1 over y, where y is not equal to 0. Secant t is equal to 1 over x, where x is not equal to 0, and cotangent t is equal to x over y, where y is not equal to 0. And we also have this figure here. The main topics that we are going to talk about are the following. We have the 6 trigonometric functions and co-functions. According to Henry, mathematics is the art of giving the same name to different things. Now consider a right triangle A, B, C with the right angle at C and with lengths A, B, and C. For the acute angle A, let us call the leg BC here as the opposite side, and then leg AC as its adjacent side. So recall that the hypotenuse of a triangle is the side AB, since it's the longest side of the triangle. Now, the ratios of the sides of a right triangle occur often enough in a particular or in a practical applications of warrant their own names. So we define the 6 trigonometric functions of A as sine A. The abbreviation is SOH or SAW. We have sine A is equal to the opposite over hypotenuse. Or in this figure, we have A over C. For A is this one A is the opposite of angle A, and then C is the hypotenuse. Then for cosine A, we have CAH or Ka. That's cosine A is equal to the adjacent side, which is B, over the hypotenuse, which is C. And for tangent A, we have TOA or TOA. Thus tangent A is equal to the opposite side, A, over the adjacent side, which is B. Then for cosecant, we have CHO or co. That's cosecant A is equal to the hypotenuse, which is C, over opposite side of angle A, which is A. And then for secant, we have SHA, SHA. Secant A is equal to hypotenuse over adjacent side. That's C over B. And lastly, for cotangent A, that's CAO or cow. We have cot A, or cotangent of A is equal to the adjacent side, which is B, and over opposite side, which is A. So if you are going to memorize the 6 trigonometric functions, you can just memorize this abbreviation. So, katowa, ko, siya, kao. and I believe most of you are already familiar of it. Alright, now for your learning activity 3, this is the first part. You are going to show that the following holds true. Each one is equal to 2 points, so all of this will be for 12 points. We'll also be posting this one in our Google Classroom. Now, let's have this example number 1. So, find the values of all 6 trigonometric functions of the acute angle A and B. So we are already given, the lengths of the sides are already given as well as the hypotenuse here. So it is easy for us to find the 6 trigonometric functions. So for angle A, the opposite side is BC. That's 3, or the length of BC is 3. And then the adjacent side is AC. It has the length of 4. And the hypotenuse is 5. Thus, sine A is equal to the opposite of hypotenuse. That's 3 over 5. For cosine A, that's equal to adjacent over hypotenuse. Our adjacent side is, the length of our adjacent side AC is 4 and the hypotenuse is 5. So 4 over 5. Next, tangent A is equal to the opposite side over adjacent. So our opposite side is 3 and then the adjacent is 4. So tangent of A is 3/4. For cosecant A, that's equal to hypotenuse over opposite. So hypotenuse is 5 and then the opposite is 3. So 5 over 3. For secant, we have hypotenuse over adjacent. So hypotenuse is 5 and then the adjacent side is 4. So 5 over 4. And lastly, for cotangent A, we have adjacent over hypotenuse. The adjacent side is 4 and the opposite side is 3. So that's 4 over 3. So for angle B, the opposite side is AC. That's 4. Or the length is 4. And then the adjacent side is BC. And the length is 3. And again, the same round, hypotenuse, that's 5. Thus, these are the 6 trigonometric functions for the acute angle B. So the same as how we found the trigonometric function for acute angle A, that's just how we would look for the trigonometric functions for the acute angle B. So sine B, opposite over hypotenuse, that's 4 over 5. Cosine B, 3 over 5. Tan B, 4 over 3. Cosecant of B is 5 over 4. And then secant of B, 5 over 3. And cotangent B, 3 over 4. So since we defined the trigonometric functions in terms of ratios of sides, so you can think of the units of measurement for those sides as canceling out in those ratios. So this means that the values of trigonometric functions are unitless numbers. So as you can observe, we don't have a unit measurement here. Since for instance, if this is 3 centimeter and 5 centimeter, so 3 centimeter over 5 centimeter, so that's just 3 over 5 since we can cancel the centimeter. Alright. let's have example number 2. So find the values of all 6 trigonometric functions of 45 degrees. So since we may use any right triangle which has 45 degrees as one of the angles, let us use the simplest one. So take a square whose sides are all 1 unit long. So just like in the figure here. So all the sides are 1 unit long, and if if in a square we know that all the angles are right angles. So if we divide it in half diagonally, so we can create AB here, and we can create a triangle ABC where C is the right angle and AB is our hypotenuse. So since each of the angles in a square is 90 degrees, if we divide it by 2, then we can create a 45 degrees angle. So we can use this figure here to answer our example number 2. So we already have the sides. If we are going to use angle A, which is 45 degrees, we already have its opposite side, which is BC, and that's just equal to 1. And then the adjacent side, which is AC, which is also equal to 1. So in order to look for the trigonometric functions, we have to know the length of the hypotenuse. So how can we do that? We could use our knowledge in Pythagorean theorem. So c squared is just equal to a squared plus b squared, which is 1 squared plus 1 squared is equal to 2, because 1 squared is 1 and 1 squared is 1, so 1 plus 1 is 2. So c is square root of 2. Thus our hypotenuse is equal to, or the length of our hypotenuse is square root of 2. So now we can look for the trigonometric functions of 45 degrees. So the angle, using angle A, we get sine 45 degrees is equal to the opposite. So if you look in our figure here, the opposite of 45 is 1 over hypotenuse, which is square root of 2. So the sine 45 degrees is equal to 1 over square root of 2. And then for cosecant of 45 degrees, that's just equal to hypotenuse, which is square root of 2 over the opposite, which is 1. So that's just equal to square root of 2. Next, cosine 45 degrees, that's just equal to adjacent over hypotenuse. The adjacent side is 1, then the hypotenuse is square root of 2. Next, for secant, we have hypotenuse over adjacent. Again, that's just equal to square root of 2, since hypotenuse is square root of 2 over the adjacent, which is just equal to 1. So square root of 2 over 1 is equal to square root of 2. Next is tangent 45 degrees. We have opposite over adjacent. That's equal to 1 over 1 or 1. Next, cotangent of 45 degrees. Adjacent over opposite. Again, it's just equal to 1. Observe that in some of our answers, the numerator is radical. So we have for sine 45, we have here 1 over square root of 2. So our answer should not have radicals in it. So in order for that to be not a radical, we could multiply 1 over square root of 2 by square root of 2. I mean, the numerator and the denominator could be multiplied by square root of 2. Both of them will be multiplied by square root of 2, so as to remove the radical in the denominator. So that's just equal to um, multiplying square root of 2 in all the sides of our triangle. So if we multiply 1 by square root of 2, that's just equal to square root of 2, and this one is also square root of 2. And then if we multiply square root of 2 by the length of the hypotenuse, which is square root of 2, that's just equal to 2. And so sine 45 is equal to square root of 2, the opposite, and then hypotenuse, which is 2. And this one here is just equal to 1 over square root of 2. So the same as sila bisan gi-multiply ninyo whole square root of 2. So that's how you remove the radical sign in your answer. Now, let's have example number 3. Find the values of all 6 trigonometric functions of 60 degrees. We can use this figure here. So in this figure is a regular polygon, regular triangle, where all the sides or all the length of the sides are equal. So in our figure, we can see that all the sides length is equal to 2. And then all the angles are also equal to each other. All the angles are equal to 60. And so if we divide, or if we draw an angle bisector here, so we can create another triangle where one of the angle is 30, the other one is 60, and then the third angle is a right angle. So we have created triangle ABC, where the hypotenuse is 2, and then one of the side is 1, since if we divide 2 by 2, we'll get 1. So this side here, side AC, is equal to 1. And if we're going to look for this side, we just have to recall our knowledge again in Pythagorean theorem. So we'll get square root of 3. So this is the solution. I mean, this is how we've got square root of 3 here. So now, using the angle A, which is 60 degrees, we can get the following trigonometric functions of 60 degrees. So sine 60, again, sine opposite over hypotenuse, that's square root of 3 over 2, and so. And if we're going to remove the radical signs in the denominator of our answers, again, apply what I have said earlier. And notice that we can also get all the 6 trigonometric functions of 30 degrees by using angle B equals 30 degrees in the same triangle ABC above here. So sine 30 is equal to opposite over hypotenuse. The opposite of 30 is 1, and then the hypotenuse is 2, so 1/2. Then cosine 30, that's adjacent over hypotenuse, so the adjacent side of angle B is BC, that's square root of 3, and then hypotenuse is 2, so cosine 30 is square root of 3 over 2. And then tangent of 30, opposite over adjacent, so the opposite side is AC, that's 1, over the adjacent side, BC, which is square root of 3. So tangent 30 is 1 over square root of 3. Then cosecant 30 is 2, secant 30 is 2 over square root of 3, and adjacent, and then the cotangent 30 is square root of 3. Now let's proceed to example number 4. We have A is an acute angle such that sine A is equal to 2 over 3. Then we should look for the values of the other trigonometric functions of A. So in here, R given is sine A, which is equal to 2 over 3. And we know that sine is equal to opposite over the hypotenuse, or the opposite side of angle A over the hypotenuse of the triangle. So we can say that 2 here is the length of the opposite side of angle A, and 3 is the hypotenuse of the triangle. So we just have to look for the other side of the triangle in order for us to find the values of the other trigonometric functions of A. So if we are going to illustrate the triangle, we'll have this one. So ABC, where C is the right angle of the triangle, and then hypotenuse is 3, and then the opposite of A is 2. So looking for B, we have 2 squared is plus B squared is equal to 3 squared, or A squared, so our A here is 2, plus B squared equals the hypotenuse C squared, or 3 squared. So B squared is just equal to 9 minus 4, that's equal to 5. And so B is square root of 5. And since we already have all the sides, or all the lengths of the sides of the triangle, we can now find the values of the other trigonometric functions of angle A. So we know, so we have cosine A, that's adjacent over hypotenuse. So the adjacent side of A is B, that's just equal to square root of 5, and then the hypotenuse is 3. So so square root of 5 over 3. And then the tangent of A is 2 over square root of 5. Cosecant of A is 3 over 2. Secant of A is 3 over square root of 5. And then cotangent A is 5 square root of 5 over 2. So that's, and we already have our sine here, which is 2 over 3. So study examples 1 and 3. If we are going to do an observation, if we are going to observe the examples, and then we also have example 3. Now, cofunction theorem. So if A and B are complementary acute angles in a right triangle ABC, then the following relations hold. So sine A is equal to cosine B, sine B is equal to cosine A, secant A is equal to cosecant B, secant B is equal to cosecant of A, tangent of A is equal to cotangent of B, and tangent of B is equal to the cotangent of A. So we can actually see these relationships in our examples 1 and 3. So for our example 1, if we look at the sine A, it's just equal to cosine B. So they are both equal to 3 over 5. That is because A and B here are complementary acute angles. And then cosine A here in our example, it's just equal to the sine of B, which is 4 over 5. Also, tangent of A is equal to 3/4, which is also equal to tangent of B. Cotangent A is equal to tangent of B. And then secant of A is equal to cosecant of B. And then cosecant of A is equal to secant of B. Also in our example 3, we have our sine 60 is equal to the cosine 30, since A and B are also complementary acute angles. And then cosine 60 is just equal to the cosine 60 is equal to sine 30. Tangent 60 is equal to cotangent 30. Cotangent 60 is equal to tangent 30. Secant 60 is equal to cosecant 30. And then cosecant 60 is equal to secant 30. So that is how the functions cosine, cosecant, and cotangent got the co in their names. So the co-function theorem simply says that any trigonometric function of an acute angle is equal to its co-function in the complementary angle. So let's have our example. So write each of the following numbers as a trigonometric functions of an angle less than 45 degrees. So we have A sine 65. So the complement of 65 degrees is 90 degrees minus 65 degrees, that's 25 degrees. So the co-function sine is cosine. The co-function of sine is cosine. So by the co-function theorem, we know that sine 65 is just equal to cosine of 25 degrees. Alright, then next we have cosine of 78 degrees. So the complement of 78 degrees is 12 degrees. And since the co-function of cosine is sine, so cosine of 78 degrees is just equal to sine 12 degrees. And then lastly, the complement of 59 degrees is 31 degrees. And then the co-function of tan is cotangent. So tangent of 59 degrees is just equal to cot of 31 degrees. So that's it. That is how, again, co-functions, the functions cosine, cosecant, and cotangent got the co in their names. So, for our learning activity B, you are going to answer the following. I'll also be posting these in our Google Classroom. Alright, thank you so much for watching, and I hope you learned something in this video. Have a good day, everyone.